About the volume and the units of the volume and the formula about uniform cross-sector objects. So the volume will be the base times the height. So today we are going to talk about like all the volumes we would like to learn over like high school. So there will be three types. So if we think about the volume, there will be three types. The first type is the uniform cross-sector. We use volume equals to area of base times the height. So it's area of the base times the height. The second one is interesting. The second one is the cone and any polygon pyramid. Okay, any polygon pyramid. For example, there's a triangular pyramid. This one is a triangular pyramid. There's a square pyramid. We can have like pentagon pyramid. Like you can think about what the shape looks like. So any types of pyramid and cone. Cone can be a special one. That's a cone. And the third one. And the third one is sphere. So for this one, the core and pyramid one, the volume will be a third of the base times the height. The base area times the height. So all of them share the same thing. So it's a triangular pyramid, right? We use the area of the triangle times the height and then times the third. If it's a pentagon pyramid, we can use the area of the pentagon at the bottom and then times the height. If it's a core, we use the area at the bottom, which is like the circle, and times the height 6, and then times by a third. So they all share the same formula, which is a third of the base times height. Okay, a third base times height. And the last one is the sphere, which is the only special one we're going to learn. The last one we're going to learn, like the sphere. The volume equals to 4/3 pi r cubed. So we have the sphere. So we know the radius. Anyone remember what's the area, surface area for a sphere? 4 pi r. Okay, 4 pi r squared. 4 pi r squared. So the surface area for a sphere is 4 pi r squared. So the volume of a sphere will be 4/3 pi r cubed. Okay, 4/3 pi r cubed. That's a special formula. Okay, so this one share the same formula, this one share the same formula, and that one is a different one. So you need to remember three formulas for the volume. Okay, three formulas for the volume. So let's have a think. Let's have a think about the first one. We are going to talk about the volume for this square pyramid. This is a square pyramid. We have end points like sharp point on top, and this is square at the bottom. So if you cut the cross sector parallel to the base, you're not going to have uniform one, but you have all squares and get smaller and smaller and smaller. So until the last point here is just a dot, become a dot. So it's all squares. Okay, if you parallel cut that, it's all squares, but it's getting smaller and smaller. So this is the pyramid formula. So if we think about the volume will be a third times the area of the base. The area of the base is just 5 squared, and times by the height. The height is 6. Okay, the height is 6. So we have, well, a third times 6, we got 2. 2 times 25, and we got 50 meter cubed. 50 meter cubed. That's the volume for the square base pyramid. So if we think about the triangular base pyramid, okay, so it's a triangle and then just keep going up. So the height, can you see the height in the middle? The height is here and perpendicular to the base. It's not a slant height, it's the from the point perpendicular to the base. So volume equals to a third times the base area. So the base is this triangle here, okay, the triangle here. So it's a half base times height. A half 13 times 14, that's the triangle at the bottom. So a half base times height. And times by 18, which is the height of this object. Yes?
For the first one, when it said 8 was 5 meters squared, does that mean what the area of the base?
Oh, sorry. Yeah, that's right. You're right.
Okay.
You're right. Yes, I was thinking that's the length. So we still have 5. Thank you for that. I will just have 5 here, and that's a 10. I get that wrong. So it's giving you the base area already, so that's just a 5. And then I use a third times the base area times by 6, and I'll just get the volume. So I was thinking that 5 is the length. So 10 should be the correct answer. 10 should be the correct answer. Okay, next one. Okay, the volume here. Well, I can use a third times 18 first. That will give me 6. And times by, well, let's have a look at the inside. 13 times 4, 15 and times by half. So 15 times 13, 65 and 15, 215. So 215 over 2. 215 over 2. No, sorry, 45, 195, 45 and 15, yeah, 195 over 2. And I'll times that by 6. So that can go 1, that go for 3. 585 meter cubed. Okay, 585 meter cubed. So I use the third times 18 to get the 6 first, and then times 13 and 15 together and half. Okay, last one for this one. Volume. Okay, this is not a street corn. Okay, this is not a street corn, but we can't use the slant height. We must use the top part and then go to a vertical line to find the height to the base. Okay, so a vertical line to the base, which is a height of 6. So it will be a third times pi r squared. For the circle, pi r squared is the circle, and times by height 6. And times by height 6. So a third times the area of the base and times by height. So we have, well, those to get 2 times 4 pi, v equals to 8 pi meter cubed. Again, you can't put pi into 3.14 because it's not asking about decimals. So you keep your answer in the exact form. Okay, keep your answer in the exact form. Okay, so that is talking about the core and pyramid. How do you find the volume of those shapes? And the last special one will be the, it's a sphere. So if you can see in that way, I can't draw. Okay, so it's a sphere like this. It's not a circle, so you have the radius and diameter. This one is asking you to find the surface area and the volume. So the surface area is 4 pi r squared, and the volume is 4 on 3 pi r cubed. So you just use the formula to find them. So the surface area for the first one will be 4 times pi times r squared. So r is a half. I'll use a half squared. So 4 pi r squared, and that equals to pi meter squared. So half, a quarter, that 4 and a quarter give you 1, so that's 1 pi meter squared. If you think about the volume, 4 over 3 pi r cubed. So we have 4 on 3 pi times 1 over 8. So that's 1, that's 2. So volume equals to pi over 6 meter cubed. 1/6 pi. So pi over 6 meter cubed. Why I'm not using 0.5? Because I think it's hard to calculate 0.5 times 0.5 times 0.5. But instead 0.5 is a half. I like to see things in fraction form, which is easier for me to calculate. So I put that into half. So half squared and half cubed. For the next one, I get diameter. Okay, read the question carefully. What you have is the diameter now. So I will have 0.92 divided by 2 to get the radius. 0.46. 0.46. Well, I can put that into the fraction form. That's 46 over 100, and that's 23 over 50. That's the radius. Not necessary to do this, but like I like to write things in fraction form. So surface area is 4 pi r squared is 23 over 50 squared. So I can use calculator for that. Need a little while to start that. We can write about the volume first. So volume is a 4 on 3 pi r cubed. R is 23 over 50 and then cubed. So we can just put 4 times pi. Pi is here, and times bracket. Control divide. You can have this fraction. 23 over 50 squared. 4 pi r squared. What you have is 529 pi over 625. To 9 over 625 pi. Also, I can copy this down and then change this. I can go 4 over 3 pi r cubed. Okay, so that's the volume. 4 over 3 pi r cubed. Okay, I have 12167. That's a large value. 12167. 93750. 93570 pi. So kilometer cubed. That's the kilometer squared. So that's the volume. Because I want to keep things in exact form, and then I can put that into calculator, give me the exact form. But if the answer is like this, I think normally the question will ask you to give a decimal places, like 2 decimal, 3 decimal places. Not going to ask you to keep this really large value. But if it doesn't say like this, what I'm giving, so you will keep it in the exact form. Okay, otherwise they indicated that. But normally they will give ask you to give a reasonable answer. So this is the second last exercise for the volume, but we covered 2 exercises today. So one is 6G and the other one is 6H. There will be more complex objects, so you need to figure out that like maybe composite shape or some shape cut by something. So you need to investigate that by yourself. But that's the basic formula here. And then there are only 3 formulas we need to know for the volume. Okay, so you can do some of the exercise now.